Hello, my name is Jackson and this is my partner.
Annabel.
Today we will be teaching you how to solve quadratic systems by graphing. Alright, so for our first equation, we have 3x squared. Sorry, that. And then we have plus 5. So there's no singular x term in the first one. However, there will be in the second one, as that is 4x squared minus 7x and then plus 1. So, as you're going to see, we can take the equation 3x plus 5. There is technically an invisible positive sign out here, which means the parabola will be facing up, kind of like that. We also see the plus 5 here, which means it's going to be up 5 units on the graph. The vertex will be up 5 units. So the vertex for this parabola would be kind of like that. It would go up like that. It's probably not exactly how it will look when we actually graph it, but it would look something around along the lines of that. So that's kind of what you're looking for. There's also the invisible positive sign here as well, which means that this graph will also be facing up. There's the plus 1 over here, which is going to make it so that it starts up 1, and this negative 7 is going to make it a bit thinner, so it's going to come up and cross kind of like this. Not exactly, as we will show. Next, you're going to be able to go into your calculator, and you're going to go to y equals, and you're going to plug these two equations in. And then the second equation in. You could put the positive sign if you really wanted to, but you don't really need to. So, in the interest of saving time, and the fact that it's not really meaningful, I won't put it in. And as you're going to see, once it loads, yeah, it looks like that. And as you can see, it's going to cross right about here and right about up there. So next we're going to go to second calc. We're going to find where they intersect, so you're going to click the intersect button. Just go around here on the first curve, around here on the second curve, and then it's just going to ask you to guess and just tap it again. And as you can see, you get the intersection of negative 0.53 and positive, and the y coordinate being 5.86. So we'll write that down here. 0.531, comma, 5.84. Or actually 5.85, because it's the 6 is after that, and that would round it up. So that's going to be your first intersection. Now we go back to the calculator, go to find the second intersection, but as you can see, it's not very viewable up there. So we're going to click zoom, we're going to zoom out, and we probably want to zoom out at around 0, 0. Right around there. And as you can see, up around here it intersects. We're going to try to find that. I don't know if we'll be able to get that exactly, but yeah, it intersects at 7.53 and 175.15, which is a very big coordinate. so the second point of intersection is at 7.53 and at 175.15. And that's how you do the first problem.
So for our second example, for first equation we have negative 2x squared minus x plus 6. And for our second equation, we have 5x squared plus 3x minus 8. And these are going to approximately be like a downwards facing parabola and an upwards facing parabola. And we're going to see where they intersect. So to do that, we're going to go to the y equals button where we are right now, and we're going to plug in our equations. So negative 2x squared minus x plus 6 for the first one, and then 5x squared plus 3x minus 8 for the second one. And then you're going to go to the graph button. And, oh wait, I should probably, this is a zoomed out version.
We forgot to unzoom it out.
Yeah, we can
So zoom
in standard 6.
That'll help.
Yeah, this is a lot more clear. And so to find the two intersection points where these two parabolas meet, we're going to go to the second button. Whoops.
Second.
Wait. Yeah, second trace up here, and then we're going to go down to intersect. And we're going to first go to the left on the blue parabola, and then we're going to go down on the red one, press enter, guess, and that is our intersection point. Wait. Yeah, okay, there we go. So for our intersection points, we have negative 1.73 and 1.75 for the first one. And then to find our second one, we have to go back to second trace, intersect, and find the right intersect. That's good. And this is our second intersect. 1.16 to 2.17. So,
and those are the two intersection points.
yeah, they're gonna be crossing like this at these points. Those are the intersection points. Yeah.
Alright.
So for our third example, we have as our first equation negative 9. Whoops, there we go. X. Oh wait, this is running out. X squared plus x minus 3 Oh, and then we have, as a second equation, 1/4 x minus 3. And pay attention here, because the second equation isn't actually a parabola, but it is a line, because it is missing the squared, the x squared. So if you graph it, if you put it into your calculator and y equals, and you graph it, it will look something like this. So notice that this only has one intersection point. So go to second trace, intersect, and I think this should be good. I think. And then, yeah, right.
Yeah.
So this is our intersection point. And the only one, 0.08 to 2.98. And that is approximately where they meet. Right here. 0.
Wouldn't go quite up to the line, but
Yeah.
still kind of accurate. It would just be down a couple.
Yes.
Alright, and for our final example, we have x squared plus x plus 2 as our very first equation. And then as the second equation, we have negative 1/4 x squared, x squared plus 3x and then minus the 7 at the end. And so obviously because we have the invisible positive sign here, that thing's going to be going up, and the invisible negative sign here means this thing is going down. As you'll notice here though, however, this is starting at -7. This is not starting till +2 and going up. So what you're going to notice when we graph this is that this is going to be up here, the first one, while the second one is going to be down here. And you might be wondering, well, what does that mean if they don't cross at all? We got the x squared plus x plus 2, and then the negative 1/4 x squared plus 3x minus 7. Oops, and it's still zoomed in from the last one, so we're just gonna zoom right out in a minute. And as you can see, there's the one up there, and then there's the one over here. They do not cross at all. Therefore, because they don't cross, there aren't any solutions to this problem. So therefore, you can just write it out, no solution. Cannot spell today, apparently. Solution. Or you can write this symbol, which also means no solution. One common mistake for these problems is that people might think, oh, they don't cross here, maybe I've done it wrong. No, you probably haven't done it wrong, it just doesn't cross ever because there isn't a solution to this equation. If you've graphed it and you check your graphing and there's still nothing, then there is no solution.
Go.
Thanks for watching our Algebra 2 end of the year project. Bye.